With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, so the question is, the Saturn is about 6 times farther from the Sun than the Mars. So we have to find which planet has first the greater period of revolution, second the greater orbital speed, third the greater angular speed. So for this, let's look at the solution. So according to question, it is given that the Saturn is about 6 times farther from the Sun in compared to Mars, so that we have to find the answers for these 3 questions. So let us assume this is the Sun. Okay, this is Sun. Now let us assume the Mars is at a distance of Rm from the Sun. Okay, this is the Mars which is at a distance of Rm from the Sun, and similarly the Saturn is at a distance of Rs from the Sun, where Rs and Rm we can say that these are the orbital radius for the Mars and Saturn. Okay, so simply we have to give here the answers for the questions. So out of which the first one is the greater period of revolution. Okay, so for this, by Kepler's law we know that the time period t square is directly proportional to the radii cube, that is r cube. Okay, that means we can say that the time period is directly proportional to the radii r. Okay, so ultimately to get the time period of revolution greater, the radii should be greater, right? Now if you see here, so for Saturn the radii is greater as compared to Mars. Okay, so for Saturn the time period of revolution will also be greater, right? So here the answer for the first one we can write here as Saturn, means for Saturn the time period of revolution will be greater as compared to Mars. Now let's see the second question, that is the greater orbital speed. So for this, let's say the B, here we have solved A. Okay, for B we have to find out of these two, that is Mars and Saturn, which has the greater orbital speed, right? So for this we simply use the formula of velocity of satellite, that is V equals to under root of capital G into small m divided by r, where m is the mass of the satellite, right? So from here we can say that the velocity is inversely proportional to under root of r. That means to get the maximum velocity of satellite, the radius should be less, right? So according to this, if you see here for Mars, the radius is less as compared to the Saturn. Okay, so for Mars the velocity will be greater. That means the orbital velocity for Mars will be greater as compared to Saturn. So for the second one, the greater orbital velocity will be of Mars, right? Now for the third one, we have to find here the greater angular speed. Okay, so for third, let's see. Now to find it, we will simply use the formula, that is angular velocity for the satellite is given by omega is equals to 2 theta divided by t. So from here we get angular velocity omega will be inversely proportional to the time period t. Okay, so here for greater angular speed, the time period of revolution should be less. But according to above discussion we have seen here, for Saturn the time period is greater as compared to Mars. Okay, it means we can say that for Mars the time period of revolution is less. That's why its angular speed will be more as compared to the Saturn. Okay, so the greater angular speed will be of Mars as compared to Saturn, because its time period of revolution is less as compared to Saturn. Okay, so this is the required solution for this particular question. I hope you like the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.